Hi, I'm Alex Potsides. You may recognize me from talks such as the little elevator pitch downstairs earlier today. I'm Aching Brain on the internet. I am on the IP stewards team. I maintain JS libp2p, JS IPFS, big chunks of multi-formats, basically most of it. If you've used some JS and there's a bug, it's probably my fault, for which I'm truly sorry. So my talk is about, it was about the state of JS, the state of IPFS-in-JS in 2022. But that encompasses quite a lot of things. So like, the elastic IPFS stuff that we heard about earlier, a lot of that is based on JS. So I'm not going to cover that because there's going to be a deep dive later, which I'm very excited about. What am I going to cover? So I'm going to talk about what I've been doing, what's been going on for the last year. So. Yeah, that's right. That's me. See me on the internet. That one. So, IPFS and JS, like why? Why would you do this? Why would you do it to yourself? Louder? Is that better? Okay, sorry, I thought this thing would amplify me. I didn't realize I had to amplify me as well. Okay, so yes, why? Why would you do this? Why? Because JS is the most commonly deployed runtime on the entire planet. Every single device that I can see in this room can run JS. And the ones I can't see too, the ones in your pockets and like everything. This TV is probably, if it's a smart TV, it's probably running JS in it somewhere. I mean, that's terrifying, but here we are. You gotta meet the developers where they are, and there's an awful lot of JS developers out there, like 12.4 million JavaScript developers in the world, and each one could be leveled up to be a Web3 developer. And why would you make them learn a new language when they can, like they're already bewildered enough by all the stuff that we talk about. Let's not make them learn a new language as well. I mean, crikey, like yeah, and more than half of developers use JS at some point in their careers. Big, more bigger. So a little bit of history. So JS IPFS started off as a clone of what is now called Kubo. If you go backwards in time far enough, you'll notice that the first commit is actually the exact same one that Kubo has, with the same, it's one again, the same message, and I believe in the same hash. I hope the same hash. I was going to check it, but then Kubo had like 13,000 commits or something, and I'm not going to page back through that while sitting down there. So maybe my talk isn't 100% factually accurate, but it definitely has the same kind of commit at the start of the history. But that's brought some interesting challenges along the way, because like as Gus pointed out, the API in Kubo is very much aimed at CLI use, and then to speed the development, that CLI interface was then turned into an RPC interface with a largely automated process, which has resulted in an interesting RPC API. Just perhaps not. Like it's great for like if you're trying to replicate a CLI, but from the point of view of an RPC API, maybe it could be a bit more streamlined. But we have always tried to replicate that API in JS IPFS, for better or for worse. And we kind of realized that like there are useful bits, and like in the same way that libp2p was split out of Kubo and multi-formats and IPLD and all that kind of stuff, the same thing happened with JS IPFS. And so we have this ecosystem of modules that you can use in your application, and it's an interesting thread for the future, because maybe you can be in IPFS without having use of all of these modules. Maybe you can be in IPFS if you just have a small focused thing that maybe speaks to your use case more than trying to include everything. So just hold that in the back of your mind. I'm going to come back to that. Yes, a clicker would be faster. Okay, so what's been going on? So traction. So it's growing. Like the use of IPFS in JS is growing. So this is IPFS core. Sorry, it's not COVID. It was tested on the way in. These are the downloads of IPFS core. So we introduced it in 2020, and it's gone up, leveling out slightly, but it's still pretty good. 11,000 downloads last week. It's quite a lot, I think. And there are lots of people using it. So who is using it? So like I said, elastic IPFS use bits of it. So UnixFS, BitSwap, and some other bits and pieces, which again I don't want to. No spoilers in this talk. Lodestar shipped the TypeScript version of the Ethereum 2 implementation, which is super exciting. So they're using JS libp2p for that, and so we've had a whole raft of improvements that make it a more viable tool to use for the kind of things that we want people to use it for. It's fantastic. TBD, I love this. So obviously we all know about Web 2, we all know about Web 3, and now people are bored of that. They've gone straight to Web 5. So TBD is building. TBD is the decentralized finance startup created by Jack from Twitter, and they're calling all their stuff Web 5. So yeah, we're totally in Web 5 now as well, which is great. I'm looking forward to Web 17. OrbitDB, 3-box, Anchor. I believe Bertie's still using some JS IPFS. Block is another TBD related thing. Yeah, lots of people are using it. Like, this is super exciting. Super duper exciting. And like we're developing it. So like we've had loads of releases. I'm not going to go through everything. There's quite a lot of stuff here. I'd meant to start a timer and I completely forgot. So yeah, Brendan, you're just going to have to wave manically if I go 5 minutes. I've only done 5 minutes. I've got 10 minutes left. Is that what you're saying? Fab. Anyway, so great. So anyway, lots of stuff. So we started with an ESM refactor. So we were dual publishing ESM in CJS. Some other stuff, and like you'll notice that like gradually, if you go back, you don't have to read this obviously. If you go back to all the release notes that are on the repo, you'll see that we've ramped down a little bit on trying to ship new features. So I mean, notable things that we did ship was like a DHT implementation. Finally after like 5 years, like the stick that people, I'd use it, but there's a DHT implementation. It's brilliant. You should use it. Super good. Please report bugs. We've kind of like tried to shore up a lot of the foundation. So a lot of the work has shifted to libp2p in the last year. So we shipped, one of the things we shipped that was quite interesting was a TypeScript refactor. So it was a ground up rewrite. Everything became TypeScript, which gives us like way better tooling. It tells us when we're like, because the thing about JavaScript is that it's really tough to do large scale refactors because obviously you don't know what the type of the thing is that you're dealing with. So we've got like, it's like, we've got this thing that was invented, in the 70s, like typing, and it's great, awesome. Don't know what took us so long. Anyway, here we are. We shipped that, and then yeah, lots of like DOS protection stuff has gone into libp2p to make it way harder to mistreat the nodes, because obviously, like particularly for Lodestar, like it's a very adversarial network. And so there's lots of improvements that have gone in there, lots of performance stuff as well. And then we're trying to like, the other thread that we've been like trying to follow is this connectivity. So trying to make it easier to talk to the rest of the network from browsers, because it's great having a DHT. If you then make a query and you get some results back, particularly from the browser, and then you can't connect to one of these nodes, it's pointless. So things like Web Transport, WebRTC are going to let you talk directly to Kubo nodes from the browser, which is very exciting. So Web Transport has been shipped. It's in Kubo right now. You can use it with a bit of custom configuration in JS IPFS, which is very exciting. Okay, so what else? So performance. We've been doing a lot of performance work. So this is one thing. This is actually from Lodestar. This is the when they changed the TypeScript implementation of libp2p. So the graph that goes blop is the higher. This is basically it's the gossip sub heartbeat. So this is when gossip sub has to do all its stuff. So it looks at like mesh peers and like gossip's data and like graphs peers and all that stuff. And you can see like there's a massive decrease in the amount of time it now takes to run the heartbeat. So this is fantastic. This is exactly the kind of thing that we were hoping to see. So we fixed loads of like performance issues and memory leaks and that kind of stuff. So if you haven't upgraded, please upgrade. It's very, very exciting. But wait, there's more. There's more. Performance improvements, more performance improvements. So this is a weird graph. So these stats are not made up. They are absolutely not made up. They are from every time we run the interop suite for JS IPFS, we transfer data between Go and JS, and then between JS and JS, and then JS and Go, and like all that kind of stuff. So this is a logarithmic graph, so that the axis on the bottom is the size of the file, the axis on the side is how long it takes. And so as you can see, like obviously it gets goes up as the files get bigger, but you can see that there's definitely some strata, and it's logarithmic, so bear in mind that as far as you go to the right, it would actually totally diverge. So obviously it's quite hard to look at, so interesting things in it. So the circled box and the blue is Go to Go. So wouldn't it be great if it was just Go? Like, if there's no JS and it was just Go, because Go is really fast, right? And JS is really slow. Well, no, actually. You can see it goes actually quite high on that list. So I will caveat that this is running on my laptop. I think the story on Linux is slightly different. I think Linux has better performance than Mac OS does. But you can go back through all the CI builds for JS IPFS and pull out these stats. So the more recent versions are even better. So this is the most recent version of JS IPFS, shipped like 2 days ago, version 65. So you see it's actually the fastest one out of all of these, which is great. I mean, it's fast. It's really fast. These are great numbers. And as you can see, so this is all the versions of IPFS that released in well, almost the last year, the last 4 releases. And you can see that it is going faster every release. We're kind of ratcheting that performance. So this is great. So also other things. So this is not content discovery. This is when you know you've connected to a peer, and this is just bit swap performance. But it's good. I mean, it's really good. You should totally use JS IPFS. Like it's really fast. That's definitely the takeaway here. And this is the non-logarithmic version, so you can see the actual. It makes a massive difference, right? A massive difference. So those are the actual numbers. So like, this is rubbish. For 134 meg file, one single file, it's almost twice as fast. Use JS. It's really fast. You know, I made the joke on stage just now that like it's a language that's completely not suited for this kind of thing, but it actually really is. JavaScript is really, really good at I/O, and most of what we do is I/O, so you should totally use it. But what's next? Is it the end of the road? Because we're about to like, you know, I touched on the renaming thing. JS IPFS, what's the future? I mean, it has a future. Definitely has a future. Like, what if the future is no JS IPFS? What if the future is just use the component? So when I think of JS IPFS, this is what I think of. So at the very top level, we have the IPFS API, so all the add cat and all that kind of stuff. Beneath that, you have UnixFS. Then you need to create a DAG out of your UnixFS objects. You have DAG PB, and underneath that, you have like the networking layer. So you have BitSwap, libp2p, which does all the really gnarly networking, and then the block store itself stores all the blocks. But like this is the perfect architecture. It's just boxes and lines drawn. And the nice thing about boxes is you can swap them out for other stuff. So what if you know your architecture was not that? What if like you just swap some stuff out? So you still have this high-level API like add cat, all the file system stuff, and beneath that you have maybe a different file system, not UnixFS. What if you had like WinFS or whatever the FS is that you need to get your job done? I mean, that would be great, wouldn't it? Maybe you wouldn't use DAG PB. Maybe you'd use DAG CBOR. You know, you're probably still going to need BitSwap, maybe, I don't know, libp2p, S3. But what if you didn't? What if you didn't? What if you did something else? What if, like, you just saw Alan giving a little talk about other things, like separating the reads and the writes and that kind of thing. What if your data store was actually a car file? You could just swap all that out underneath, as long as it all implements the same interface. This is great. So, like, maybe this is the kind of thing that you should be building to, like, answer your specific use case, rather than trying to pull in all this other stuff that you don't need. So that's the roadmap, basically. So we're gonna rename IPFS. It's not gonna try and follow Go's development model anymore. We're gonna have individual components that you can pull together, create your thing, nice, lightweight, easy to use, hopefully. A lot smaller. We're gonna go web first. So we don't want to use Node APIs, preferably. Obviously, there's still some Node APIs for stuff that's only possible in Node, like TCP and that kind of thing. But for the most part, it's going to be web first, smaller, more lightweight, easily composable. But you know, we're also going to have an easy way to get started, which is going to be Pomegranate, which will have like some sensible defaults, useful transports. But they're going to prioritize, the browser and talking to nodes remotely and that kind of, obviously nodes remotely, talking to server-side nodes and that kind of thing. And loads of libp2p improvements that we still want to make. So you should come to the libp2p day. I'm going to be there, going to talk about lots of stuff. It's going to be really good fun. But yeah, you can totally choose your own adventure. I'm almost done. We need some help naming. Like, naming is the worst. So much energy is going to be expended on this. It's going to be great. This is the issue. So you should pick up your phones right now, get that QR code, and it will take you to the GitHub issue with a poll where we're going to decide, we're going to seize the means of production, we're going to decide the name for whatever the next thing is called. Pomegranate is the name at the moment. I'll tell you why later, but not now, I'm running out of time. But it's a temporary name, it's not available in NPM, so we can't use it. We're going to use something way better, but we want your help to name it. So please do grab that QR code. That is it. That's the end of the beginning. Like Brendan was saying, the best times are ahead of us. They definitely are. That's me.